check that earlier. Right, I'm going to go to share screen and we will get this show on the road. Okay, so welcome to everybody who's come to this webinar with myself and Sarah Logie, and we're going to look at, basically we're looking at hoof horn and a number of things that can go wrong with it, not the sort of traumatic injuries, but more infections and the things that happen within it. So we're going to have a good go at that. I'm going to give a little lecture to start with, looking at hoof horn. Then Sarah's going to do her thing, her specialism, and then I'm going to come back and have a look at some of the other things that can go wrong with hoof horn. So we have an agenda here. We are never so pedantic that we don't alter slightly with the way things are going, but we try and stick to it as much as possible, and we will try and finish before 9. So as you can see, we're in the introduction, and my first lecture is going to be what is hoof horn, and I would hope most of you would find that interesting. What I'm struck by is that we work with hoof horn every day of our lives. We have those hooves in our hands, and sometimes a lot of the things about it is a mystery. So I'm going to just look at the basics of hoof horn. And then, of course, I'm going to keep that shortish, and we're going to break for a scavenger hunt, our famous scavenger hunt. And I want to ask all of you not to injure yourselves trying to get the product, shall we say, that we're going to be asking for. And for those of you that haven't done it before, the quicker you get a photograph in of what I asked for, the more chance that you have to win a book. And that book is going to be The Farrier. So a big hefty book worth £145, so I don't know, $180 worth, similar amount of euros. So please have a go at it. You never know your luck. We have a different winner each time usually, so have a go at that. I want to remind you to use the question and answer function that you'll see on your screen to ask questions. Sarah and I, there's quite a biggish time left over at the end for question and answers. We really think this is an important part of this event, so please have a go at that, and we will do our best to answer them. If there are lots, then we will get stuck in while the other person is speaking, but it's an important part of this webinar, and so ask what you like. If we can't answer you, we will say we cannot answer you, but we will do our best to do that. Then we'll have Sarah. We're going to have our usual break because it's a 3-hour event. You need to have some coffee. Some of you need to have something to eat, whether it's breakfast, dinner or tea. Please do the poll as well. The poll's important to us. We do change things with this webinar according to what we find in the poll. So it's really important to us. And then there's a quiz with another prize, the hoof of the horse, again worth £85 and over $100, over 100 euros. And then our final event, or our final lecture, I should say, is me doing diseases and conditions and infections of the hoof capsule. And then, of course, we're going to go into question and answers, which is important, as I say. I will try and update you about some of the other things that are going on along the way. Before I move on to my lecture, I would just like to remind you about our partners. Our partners are very important. They help put this out to people and give them discounts. So if you're part of an association or group and you're not getting that, encourage your association to contact us, because we're always looking for new partners, and we're always happy to do that, because the most important thing to us is the information and the knowledge and the education that we're putting out. So we're really happy to give discounts to groups, but they have to do their bit. They have to promote it to you and let you know. So that's the list of our partners for this webinar. Warwickshire College, which of course is a farrier college in the UK, the American Farriers Association, the British Farriers and Blacksmiths Association here in the UK, Norwegian Farriers Association and the Swedish Farriers Association have supported us for a long time. We're really grateful for that. The Humble Hoof, if you want to listen to a great podcast by Alicia Harloff. Mullins is also a podcast, and they support us. And the Study of the Equine Hoof, of course, with Lindsay Field, supports us and partners us. And our last partner there is the Farriers Journal. That's the European Farriers Journal, put out by Florian Hefner. And we've been having a great partnership with him because we've done a deal which will get you a free copy of that Farriers Journal, but I'll tell you about that a little bit more later. The discount code for this webinar is infection. So not a particularly nice sounding discount code maybe, but easy to remember when in the light of what we're doing this evening. And so you use that to get discounts on books, you use it for webinars. And I just want to remind you that past webinars are available. All the time we're getting new people come in, and some people seem to discover almost by chance that they can get this discount. So I decided this time to try and remind you that they are available. You just have to contact Sophie, and that's the usual way. That's sjcurtisbooks@gmail.com, and you'll get Sophie for that. So just a reminder of all those things. Okay, I'm going to look at just having a think about what is hoof horn. I don't know if I can move this up there. Yeah, let's just move up there. Okay, so really, I just thought that before we did a webinar of this type, then it's great just to sort of remind ourselves of what it is we're talking about. And I'm sorry if that sounds a bit too basic, but I think for all of us, even for me preparing this, and I've never given this lecture before, was helpful to remind myself about this material that we work with every single day of our lives. And of course, that's a lovely CAT scan, an earlier one. It's probably 12 or 13 years old now, but showing the hoof capsule, removing it, and then showing everything that's inside. So it's just an overview. There's no real chance to go into anything in detail. So we're going to look at the equine hoof capsule. I'm going to try and think of some of the important functions that hoof capsule is there for. I want to think about how it grows, and maybe at a microscopic level how it grows. And then I want to think about its material properties, because it has some extraordinary properties, and sometimes because we're so used to working with it, maybe we take it a little bit for granted, and I want us to think about those a lot more. So let's just check terminology, and especially there is a slight difference in terminology between UK English and US English, and I think there's other examples where there's lots of differences, but on the hoof there is a slight difference in the understanding. But my understanding of what the hoof or the hoof capsule is, that it's the adapted epidermal covering of the digital cushion. And the reason I say that is because I know in the US often the hoof is used synonymously for the foot. But the equine foot, certainly in the UK, what we say is that it is the hoof and all that is contained within it. So we try and differentiate between the hoof and the foot. So I just want to make that clear that when I say the hoof, I'm actually only talking about the surrounding horn. When I say the equine foot, I mean everything in it. And so we see the picture at the bottom left. We see a lateral view of a hoof capsule, and the radiograph on the right. The dotted line is just trying to show roughly where the coronary band is. And so even the bones that we see in that radiography are considered to be part of the foot, the equine foot. They're of course not part of the equine hoof. So I think we ought to think about integument, and we can see that diagram on the right, and it's really showing the integument of a human being. So maybe we might say the back of our hand. But what is integument? Well, integument is the organ that covers the exterior of vertebrates. And of course, with us, we have skin and a little bit of hair. With most mammals, skin and lots of hair, whether it's a dog or a horse or a cat. With birds, we have skin and feathers. And with reptiles, we basically have a covering of scales. So all of those are integument. But that's the first thing that, by me describing how different they are adapted. So it consists of dermis, epidermis, and subcutaneous layers, and you can see that shown here. Epidermis, which we would consider to be the horny hoof wall. The dermis, which, if it's the hoof wall, we'd say is the lamellae, and then underneath that, the subcutaneous tissue is what is attaching it to the distal phalanx. So wherever it is in the body and however it's adapted, we should be able to recognize it. The other thing to think about integument, when the definition says that it mediates between its organism and the environment, that all sounds very complicated, but of course, should we say it's the barrier between the organism that it's covering and its environment. And one thing we sometimes forget about the hoof when we talk about the environment, the thing that's affected most by its environment is the hoof, because it's standing in the ground, whether that's bedding in a stable or soil or on rock outside. Whereas the rest of the horse's body, of course, is mainly affected in the environment by the air around it. So it's the barrier between the environment surrounding the organism, in our case the horse, and its environment. And of course, in regions of the body, it has a very specialized adaptation. So for the horse, for most of its body, it's covered in skin and hair, but down there at the surrounding the digit, of course, it's really very, very specialized for an obvious number of reasons. So the integument is adapted according to what it's supposed to do. At the top right, you can see a human fingernail, and anatomically, of course, a human fingernail and a hoof is very, very similar, but they do two totally different jobs. And we know of people that lose their fingernail, and it might be painful, but they can pretty much carry on. A horse, of course, is committed to standing on the tip of its fingernail, and that's a far bigger deal. And we can see there that there are great similarities anatomically between our finger, our digit, I should say, and the equine digit. So at the extremities of the digits, the integument adaptation is described as claw, nail, and hoof. So we call it our nail, we call it on the horse the hoof, and of course a claw is whether it's a cat or birds. So that specialist adaptation at the end of digits, which really has a far greater variety than there is in the rest of the body, have these different names. So each individual species has a very modified integument on the end of its digit, and that depends on its use, but especially locomotory. So in fact, if we think about cats, they have sharp claws because they need to climb trees. Our fingernails really are just a little bit of stiffness at the end of our digits because we have 5 digits. And the horse, or even, should we say, cattle or sheep, because they stand on the tip of their digits for locomotion, then the hoof horn, that adapted integument, really surrounds most of the digit. And yeah, so we've been through that. And of course, the other thing is that the integument of ungulates is really very adapted because it has to give protection, grip, and resistance to wear. So newly germinated living cells undergo cytodifferentiation. What does that mean? It means that it's only at that point that they change to suit whatever their purpose is. And there's a little diagram there on the bottom left, which I have used in a couple of books. And you can see that the cell on the left is normal. It has a nucleus. I would say it's a very simplified cell. There's a lot more going on in cells at that point. But the middle B is where the cell starts to die, starts to flatten. And more importantly to us, the keratin tonofilaments, those strands of keratin, start to flatten out. And we know that, of course, that when things are aligned, they have great strength. Even things that we'd consider to be quite weak, like, should we say, drinking straws, if there's a bunch of them held together, then they immediately get a lot of strength, especially in lengthways direction. So I did this diagram. I've done it in a number of forms, but this is really trying to represent the papillae. So we can see the papillae projecting down here and here. And of course, we must remember that in between the papillae, and let's get a picture of, this of course is a hoof capsule, and this is the coronary band stripped back, or peeled back, I should say, the skin, and we can see all the papillae here. So there's a multitude of them generating the hoof wall. But what's often forgotten, and I keep hearing it stated, that the hoof wall grows from the papillae. Well, actually only 50% of the hoof wall grows from the papillae. So we mustn't forget that. In between each papillae is a germinative area. And it's producing cells in this direction, and off the papillae, they're growing at almost 90 degrees different direction. And this is a two-dimensional diagram, so of course they're growing towards us, growing away from us, and they're just radiating out of these papillae. The moment they touch, and we can see some desmosomes on the diagram on the left, the moment they touch these cells, then they're joined by desmosomes, which is like spot welding, which really holds them very strongly together. And then they start growing down in this direction. So the point I'm making is that there is a direction of horn generation, and then there's a direction of growth. So we all think of the hoof wall growing down from the coronary band towards the ground, and of course that is what it does. But prior to that, it starts to, it's generated off both the papillae and the area in between, and it's only when they touch and form that bulk, and they have died and they've become squamous cells, that they move down as a whole body of horn. We tend to say that the hoof capsule has 5 distinct types of horn. The 3 main ones, which we can see in this almost desiccated sample or cadaver sample, is the hoof wall at A, the sole at B, and the frog at C. But of course, there's the 2 lesser types of horn. The white line, although we can't see it, is actually here, joining the sole to the hoof wall, and it's a very elasticated horn, and it needs to be because during locomotion, of course, this sole is moving up and down, and the hoof wall is moving in and out, and even more complicated than that. So parts of the hoof capsule are moving in two different directions. Of course, it needs an elasticated horn to stop it pulling apart. And the last one is the periopal, still often debated about what it's there for. I think in simple terms, it really, there's a gap between where the skin finishes and the hoof wall starts. And in simple terms, it covers that area. So it's protective to try and stop microbial invasion. Often people say it's involved in evaporation and control of moisture. I'm not 100% sure of that, but who am I to say? Maybe it is. It's definitely there though to seal that joint. And all of these areas have their own Latin names. For those of you that are total nerds, you can learn those Latin names, every single last one of them. But one thing I want to say is because in recent years, I've particularly been a proponent of trying to stop people saying the solar hoof, because actually solar relates to the sun, and we see a happy little sun there. But solia relates to the bottom of the foot. And we can see here in Latin, it has an A at the end of it. So I think we ought to try and be correct and call it the solia hoof, if we want to say that way, or the solia side of the foot, and not solar, because it's got nothing to do with solar heating or solar flares from the sun. Most of our tissue is where it is generative, so in other words, where it grows from, it's also connective. So in other words, the frog and the sole that we see here are generated by the sensitive frog and the sensitive sole, I should say the dermal frog and the dermal sole. So it both holds on to that epidermis, but also generates it. Of course, where the hoof capsule is different is that the hoof wall is generated by the coronary band up here, but its connective tissue is the lamellae. So they're two different things, and we see this slice through midway through the hoof capsule, perhaps the lower third. And here we see the hoof wall, zona alba, so that's the inner hoof wall, and then we can see the lamellae, and here we see the distal phalanx. So all the other horn tissues, the other four, are both generated and connected by the same tissue. But with the hoof wall, it's generated and then it's held in place. It's, as we know, the horse is suspended by its lamellae, and they are two different structures. So what are the functions of our hoof capsule, which surrounds our digit? We can see this picture here with both the digital bones, the navicular bone, and the deep digital flexor tendon coming under there, and this plantar cushion. Well, of course, one of the, perhaps the main purpose of the hoof capsule is just to protect all that tissue there. We certainly, all of us will have experienced horses that have partially avulsed a hoof or damaged the hoof, so tissue is exposed, sensitive tissue, dermal tissue, and of course that's fairly disastrous for the horse. It means we have to take great care to stop there being damage and infection. So protection is very important. But we mustn't forget as well that there's been a lot of years of the hoof capsule being developed and evolved because it really aids the horse with locomotion. It provides grip so that the horse doesn't slip over, and it provides purchase to give this horse this incredible athletic ability. We know that hoof horn has plastic deformation. In other words, over time, it can be pushed out of shape, it can be compressed, or it can be bent. So those are the two main plastic deformations. But of course, we know we have elastic deformation, which in other words is when it springs back, and I'm going to show you a little video of that. But the interesting thing about hoof horn is because it has both of those properties, it's actually called viscoelastic. So it can both be deformed over a period of time, but it also mostly springs back. So if we see, we have an example of elastic deformation there, hoof capsule that's just been removed, and we can squeeze it in our hands and it springs back to shape. And this is just to demonstrate plastic deformation. Clearly the hoof wouldn't squash as easily as that, but over time the hoof does get squashed or bent out of shape. But as I say, it has both those properties together. A diagram I've used a number of times originated with Lungwitz, who showed that the hoof capsule doesn't just open and close, but it deforms in other ways under use, under I should say loading. And of course this view of the hoof capsule given to me kindly by Page Poss, we see just how thin the hoof wall gets towards the heel, and obviously that really aids this ability to open and close. So I just wanted to show, because it's coming up later, a little bit of anatomy, and that we can see this slice through the hoof capsule, going from the lamellae here right to the outer hoof wall. So this whole body of hoof is called the stratum medium. That's its name for all that horn that we see, that we call in common terms the hoof wall. But the zona alba is this area here. Now, it might not look like a white area, which of course is what zona alba means, but that's because this is a slide and it's been dyed, and we're going to look at some pictures and see that the zona alba is that white unpigmented area. I think we don't quite know why it's a different colour, but if we look at it, we can see this is the area of very large horn tubules. So I said about the papillae, that they generate these horn tubules, and in between we get the intertubular horn generated, and it's about 50-50. So about 50% of the hoof wall is horn tubules and 50% is intertubular horn. And it is not that the intertubular horn is a glue holding it all together. It's just more horn cells. It's just, as I tried to describe it, it's been generated in a different direction to the horn tubules. Otherwise, it's just more horn. And we can see this, this white zone here, this zona alba. The other reason I want to show this picture is this, this slice through the hoof capsule is actually in line with the direction of growth, and that's why pretty much we've got parallel horn from the coronary band down. It's only at the end which has almost certainly been rasped. In order to get this picture, we did get a little bit of distortion here, but I wanted to show how wide this zona alba, which is showing up as the darkened area, is in the hoof capsule. And Sarah is going to go to great detail to describe how this is damaged, and she's going to do that during the next lecture. These little arrows just represent the fact that the hoof capsule, when it's healthy, is really very good at keeping microbial infection out. As we know, there's microbes everywhere. Hoofs stand in all sorts of environments. All the time they are bombarded with microbes, but the hoof capsule is very good at keeping it out. So we're going to be looking at some of the times when it's not great at keeping it out. So just to finish, I'd like to say that hoof horn is an extraordinary biological material. It's really tough. It's taken a long time to develop. It does its job extremely well, but infections can damage it, and that's what we're going to be looking at. So, thank you, ladies and gentlemen, for that part of the presentation. Just a reminder, don't forget to use the question and answer function. It really helps us if you go in there, ask a question. That helps us to get a few and make it a good discussion period towards the end. I want to remind you that I do free podcasts, the Hoof of the Horse podcast. You've only got to Google that, you'll find it. If you've never listened to a podcast, please have a go. It's really easy. It's just click and go. And I would like to think that they're both interesting and informative. And if you're happy to come to this webinar, I'm sure you'll be happy to listen and try some podcasts. I think we're well over 50 podcasts, perhaps heading for 60. We have new ones coming out all the time. Please give it a go if you haven't tried it. So now, this is where we have the scavenger hunt. This is the part that I hope that you'll be able to find the object that you're asked to find. You send a picture of it to sjcurtisbooks@gmail.com. So you send it to Sophie, and we just judge on the first correct one coming in. So this is your mission today. So it's to send a picture of something made from a hoof. It's as open as that. Best of luck. Any of you that have anything made from a hoof, please take a photograph of it and email it in straight away, and the prize will go to the first one that comes in. And in the meantime, we're just going to have a 7 or 8 minute break, and then of course we'll have Sarah coming up with her presentation. Thank you. Hi, Sarah. Are you there?
I am, but for some reason the virtual background has obliterated me as well. There we go. I'm back.
Have you got a light that you can put on yourself?
2 seconds, see if I can change something. Hang on.
While Sarah's trying to get a lamp, just to remind you of why we've asked her to speak. The first thing is that she did her fellowship thesis on this very subject, and she's going to be talking about that. But she started in Scotland and has stayed in Scotland. That's a little bit better there. At least we can see you almost like a Rembrandt painting with a...
That'll do. That's close enough.
Okay. So, Sarah, I was going to just start on your introduction, but you haven't just shot in Scotland, though, have you? I think you travelled a little bit, didn't you?
Yeah, quite a lot of time away when I got qualified. So it was very good experience between America and New Zealand, and then quite a lot of time in various places in Britain with different farriers, just to get a better view outside of what I'd seen as an apprentice.
Outside, but you returned to your beloved Highlands.
That's the one, where the roots are.
Yeah, so you're up there near... How far from Aberdeen are you?
Long way west. Probably it's a good 3-hour drive, and I'm about 4 hours north of Glasgow and Edinburgh.
Okay, so right in the middle of the Highlands then.
Yes.
Okay. So anyway, so you travel quite a lot, and you also passed your diploma with honours, which apparently made you the first female farrier to do that in 650-year history of the company. So, and you passed your associate in 2012. So how did you find that then?
Feels like a lifetime ago, but at the time, it was something I'd always wanted to do. The theory side of it was I enjoyed it because it really let me stretch as far as I could go. Obviously, at the time, the practical side was more of a challenge, and I probably didn't get the best preparation. I was far better prepared for the fellowship because I went to the right people. For my associate, I kind of went on what I knew. So little things like going in, having never used a striker, I changed that for the fellowship because yeah, that makes a big difference. So yes, there was various aspects that were difficult, but obviously it went well, and enjoyed it. But I have to say the fellowship exam itself is actually more enjoyable, if that sounds a little bit strange.
You're nerdish enough like me, Sarah, to actually enjoy exams, but that's a real worry. So we're going to switch to the next slide. Just moving on to the fact that you've been involved in the Farrier tuition group for the last 3 years. And I was stunned when you said you'd tutored over 60 pupils, but I certainly believe you, Sarah, because when I went to the States recently, since the last webinar, and I actually advised people who are interested in doing the associate to see you. And of the 6 people I advised, 3 of them said, "Oh, they're already doing that." So, so far and wide as your courses, and I know you've been a little bit struggling to keep up with them, haven't you? But
it has been pretty full on, but that's the joy of the internet, because actually it means I couldn't do that without the ability of being able to do it remotely. So yes, I can still be up here and still be able to deal with people. I think we're up to about 7 different countries now that we've had students in, which is fantastic.
So there's a plug for Sarah. Anybody who's interested in moving towards the associate or the diploma, should contact her, and we'll see what happens. Now, Sarah, what I need you to do is for you to share screen. I'm going to stop share, and you need to share. And you are the mystery woman, I'm afraid, but I know the slides will be well lit. Okay.
Yes, slides will be fine.
Off you go, Sarah. Thank you.
Right. So apologies about the lighting, but it doesn't matter for the slides. There's probably going to be a degree of repetition on the anatomy side of things, but then to be fair, as long as you're not falling asleep, I don't think that's a negative thing. We've covered briefly what I've done on the run up to the fellowship. The fellowship itself, I looked at the studying of what at the time we were calling Seedy toe. So excuse me when I call it Seedy toe, although the KDZA term on the title here I'm going to cover. But fundamentally, it was bacterial and fungal infection of the inner hoof wall was what I was looking at. So what I'm covering today is we're going to look at the condition itself, the anatomy involves, the 2 classifications that came as a result on the work prior to the thesis, and also looking at donkeys, which is not something I've really covered before, but have been aware of the fact we're concerned. So what we're seeing is various manifestations of this fundamentally the same problem. We've got a bacterial and fungal issue, which may result in feet that appear to be what we would generally call poor. So we've got a black and white line that isn't that healthy and may never appear to dramatically improve or cause major issues, but it's always there. We may have feet that have got obvious small defects, quite often a little toe crack, that when we get into them has got powdery horn that we appreciate is fundamentally an infection, but it tends not to bother us too much, so half the time we vaguely ignore it. We may have feet where you've got a far bigger invasion, and those feet quite often, even if they haven't been opened up like this one had when I first met it, they sound hollow and you can see a bulge in the wall and tap them. Now this x-ray actually relates to this foot, so you can see the extent of the cavity. Then you'll get other feet that if somebody else has been at them, it's rather obvious what's going wrong. But fundamentally, we have a breakdown on the integrity of our hoof capsule. So what are the consequences of this? Well, it can range from anything from slight annoyance and a little bit of frustration that it doesn't seem to get better, or on the feet where they're more badly affected, we may end up with shoe loss. Then we've got a hoof capsule that's more broken. You get a further shoe loss. We've all been into that vicious cycle where we're annoyed, owners cross, and horses potentially getting footy and losing performance. This can end up with a management headache. It costs money, takes time. Again, owners aren't happy, we're generally annoyed, and horse isn't at its best. Worse from this, we can end up with actual lameness. Now, the feet that are poor may be the footy type of lameness. The foot that I just showed you with a big cavity in the x-ray, those ones can actually be far more severe. And I was called to that horse because it was lame, and it had actually therefore been diagnosed with laminitis because P3 had become so destabilized that that was the ultimate conclusion, is we've now got a laminitic condition because the pedal bone has lost its attachment. So we can live with the slight annoyances half the time, but when we get into these bigger issues, then we start to feel that we have to do something about it. So what's actually happening in all of these feet? We have a keratophenilic fungal infection, and we've got sulfur-reducing bacteria. So what we find is that bacteria come along first, munch the horn cells, and the fungus follows it. And we get a breakdown between the stratum medium and the stratum internum, which is why we don't have a blood supply involved, in that it's not quite that deep. So when we take these cavities out and we remove the cheesy broken down horn, unless we get too enthusiastic with our knife, there should be no blood involvement. And this image just shows under a microscope where all these bacteria are on the horn cells. So this is where we're on to a little bit of recap. So when we were talking about the hoof wall structure, I'm not going to go through it entirely, but the zonal part of the wall is what's important for us when we're talking about this particular infection, because it's not circumstantial where the infection occurs and why it starts where it does. And an understanding of that is very important for when we get further on at how to treat it. So it's all about location, location, location. It's there for a reason. Again, another slide we've already seen. But when we go back to what we were talking about in the zonal areas of our tubular horn, our outer layer, our protective layer, is more dense, smaller tubules, and it is less easy for the opportunistic bacteria to start in. Whereas our softer, more flexible portion of the hoof wall, in where our zona alba is easier in that you've got more disulfide bonds, it's less packed, and it's more digestible matter. So in reality, it starts in the easiest place it can, it's most flexible, it's softer, and there's plenty of food stuff, for want of a better way of putting it. So again, it's logical. These bacteria and fungus are found in the soil, they're found in the environment, and going back to what Simon was saying about the hoof capsule has to deal with the environment far more than any other part of the body does. It's exposed to these pathogens basically every step it takes. So unless we can deal with the whole picture, we're probably not going to deal with the infection very well. But again, the logic of why it occurs where it does, the bacteria reduce the sulfur bonds between the keratin molecules, the fungal species digest the elements of keratin, we end up with that digested cheesy matter that we see, or the overall poor quality horn where you haven't got such an intense focused infection, but there is a degree of infection throughout. I would relate it to the difference between having a cut that then becomes pussy and very infected, or a general skin issue that you are irritated by, that it's annoying, but it doesn't tend to get as bad as pus whooping. Light bulb moment. So if we look at the history of it and the confusion with names we kind of have to deal with. So historically, it is recorded back in the 1800s, a type of sand crack called seedy toe, because it was often found out the toe and referred to as that. So like that little picture I showed with the small cut, small crack right at the toe. And when we think about the anatomy of the foot, we have the crena there for the pedal bone. So again, we have a slightly weaker point that is more available to be invaded, and particularly in a horse where that area is not protected. So an unshod horse, we may see it, or if that area is weakened further, then again, it's more likely to be infected. By 1884, Lungwitz was talking about hollow wall. So again, that foot I showed where, although the bottom had been opened up a bit, you could tap the whole thing, and the X-ray showed how far the infection was going. Going into the 1990s, white line disease became the term, and it's not accurate in the fact that, as we've just discussed with the anatomy, it's not actually the white line that it infects. The white line may be a point where we see the start of the infection, but the white line is produced from the bottom of the pedal bone. So when we're going up to the coronary band following this, we're definitely well and truly out with the realms of the white line. We then had some of the studies on onychomycosis, which is actually the fungal aspect of it. And when I started my thesis, I was quite determined that I had to find exactly what was causing this problem, and then found out pretty rapidly that there's actually hundreds of species of bacteria and a main family of fungal species. So to try and isolate a particular one was a little bit going to, well, I'd have never got a thesis written. And at the end of the day, when you have a structure that should not have any other bacteria or fungus in it, it doesn't matter what they are, you just don't want them. Then it was found that we had these two conditions together. So the white line disease talked more about the bacteria, the onychomycosis talked about the fungus, and then they realized that these two things appeared together. In an attempt to clarify things, prior to writing my thesis, I decided to use the seedy toe term purely because it meant something and nothing, but everybody was familiar with it. It wasn't accurate, but it allowed me to apply a classification of type 1 or type 2, which then allowed me to focus my study, which was on the type 1 structural cases. And what I've realized looking into all the studies that have been done previously, the written literature about it, and cases I'd seen myself, was there was very much two occurrences. There was either these cases that occurred in one foot and were quite dramatic, or the cases that actually tended to affect more than one foot and were less intense but equally annoying effectively. So if we're going to update it, Simon came out with the term keratolytic disease of the zona alba. I just kind of wish he'd helped me do it in 2017, because then I could have had the brownie points. But anyway, when we look at what that means, keratolytic is pertaining to keratolosis, which is the breakdown and decomposition of keratin, which is exactly what we are seeing. The zona alba is the unpigmented axial portion of the stratum medium. So again, it is what we're seeing. It really is a moment of does exactly what it says on the tin. I just wish I'd come up with it. But anyway, so you will excuse me when I slip into seedy toe, because it's been a number of years and a term I'm quite comfortable with. So the classifications are still relevant, even though we've moved on maybe with our main term. It is still relevant to be able to clearly place these occurrences into two types. We have our structural cases where an insult or weakness occurs in the foot. It's a fundamentally isolated mechanical cause, and it actually tends to be the ones that are easier to deal with. It's the ones I focused on for my thesis because there was less variables involved, and I'll explain that in a minute. The systemic cases, the type 2 ones, tend to be the poor quality feet. It tends not to be such a major infection. But it does tend to affect more than one foot. And it's the cases that cause greater frustration, but are harder to deal with. So the type 1 structural cases, as per my fellowship thesis, which is available, you can find everybody's thesis online, which I think is a fantastic resource for anybody, and particularly if anybody's thinking of doing their fellowship. All of us towards the end have got points for further study. So there's areas there that people can pick up and run with if it's interesting them. So the main reason I started was frustration. I got really upset with the fact that it was a condition that we saw regularly. You would go to an animal, you'd find a cavity, you'd open it up, you'd give it a clean down, you'd do whatever hoof care was required, and you'd say to the owner, can you keep it clean and dry? And mostly they'd smile at you and say, yes, Sarah, as they turn it back out in a bog, because that's the option they've got and they can't control that. So my thought was, if you have an infection in a wound, you would not clean it and then put it back out into the environment without doing something to protect it. So if we consider a wound tissue, horn is a tissue, so how can I treat that, protect it from reinfection, and therefore allow it to grow and effectively heal? So this was what kicked off the start of a fellowship thesis. So why would we see infections appear in an otherwise healthy hoof wall? Simon covered the anatomy and actually what an amazing structure the hoof capsule is. And why would we have an issue on something that works and functions well? So it's an incredible structure. We've talked about its capabilities of movement and flexing, and it can take load, and it can protect the animal from all this environment, even when in reality the animal above it might be pretty wonky, conformation's not great, we can still get a decent foot. So one of the main reasons I discovered or realized that these problems occur in feet was imbalance. As soon as you change the loading on the hoof capsule so that it cannot bear the load equally, then you have problems with stress and strain and tearing going through the wall where it shouldn't. I'm going to cover this case more in a moment, but it was probably one of the best ones to show why imbalance can start these infections. So the other one is overdressing the hoof wall. Again, if we go back to our anatomy, if we remove that outer layer of hoof wall where our tightly packed tubules are, our protective harder layer, we're exposing the inner layers that really shouldn't be having to deal with the environment as well to stresses that they're not fit for. So overdressing a toe, you can see here from underneath, this white line should be nowhere near the outside as it is there. It should be a lot more protected. And it just means that you're more likely to start seeing these issues. One of the other problems is gravel runs, and this can be quite a common one, particularly in an unshod foot, where you see the overloading in an area, packing dirt and gravel into a white line and generally causing pressure. The wall obviously has to give, and the bacteria in the soil, which we've already just said, has packed in, so it's been mechanically forced into this area. And of course, it's an anaerobic bacteria. It's a perfect environment for it. Long, strong feet. It's one of the ones I realized that you get feet that are so strong that a slight crack or an opportunity in it, that wall doesn't break away. So you are more likely to have a cavity maintained there and stay there long enough for the bacteria to start going. You'll quite often find this foot on the right, this was quite a bulge, and the way the horse was loading its foot, it was literally bending the hoof wall in a way that created a weakness at the bottom of it. Big feet like this, where you've got a big horse, you have a slight crack, it doesn't disintegrate and fall away, but the bacteria works in behind that crack, gradually weakening things. So these type 1 cases, how do I look at them? Well, first thing is work out why it's there. If you don't know what caused the problem in the first place, you're going to treat it, waste your time, because it will be back again. So with any issue that we've looked at, regaining balance and creating appropriate loading is one of the most important things with hoof care. And going back through all these webinar series, I think that's come up quite a lot. Preserving the wall. Again, we've had other lectures talking about this is an incredible structure, but we have to treat it with respect. You can control it, but don't weaken it. Once you've looked at all of those things, then you can start addressing the infection. And that actually is the easiest part of the whole job. So the goals for my thesis, I'm not going to run all the way through it, but there's a few highlights that I think are interesting. Is to find a treatment that would prevent reinfection. Going back to my thought of a wound, a damage to a tissue, is you want to protect it. And obviously, historically, it's an anaerobic bacteria, so we were always told do not cover it, with good reason. So I wanted to look at whether you could treat it by medicating it and filling it, but that it could be done day to day, out and about, while shoeing, because invariably these cases turn up out of the blue. It was fine last time. This time, 6 weeks later, we've got a problem and I need to deal with it. I can't ask the owner to take the horse somewhere to treat it. I want to be able to get on with it there and then. My other feeling of this was it took out one variable, which was owner management. And if I could not have to rely on the horse owner to do as I asked them to do, if I was in control of its treatment, I was probably going to get a better result. Through doing this, if you could prevent reinfection, I wanted to see whether we could improve the hoof renewal times and reduce the time the horse has a compromised hoof capsule. If I don't have to go back in with my knife to remove more infection, we get a solid foot back sooner. So the objectives were to determine whether by debriding an area of seedy toe, structural seedy toe, KDZA, see, I told you I'd slip up, applying a topical treatment and then filling the void, whether we could prevent further infection. So briefly looking through some of the results, the infection frequency turned out to be the most telling result I was getting. My thesis revolved around 4 study groups. There was a control group, which was traditional treatment, open it up, ask the owner to keep it clean and dry, and the results were based on whether there was any visible infection when I returned. The iodine group was iodine under a thermoplastic patch. The copper sulfate group was a powder underneath the patch, and SD115 was actually silver, a silver gel that was made for me by a company that had a silver hoof spray, but I'd asked them for something stronger because I wanted something to be longer lasting. Unfortunately, at the time, it actually, as you can see from the results, it wasn't as useful and it wasn't statistically effective. I kind of still think that might be a route that development might create a good product from. But as you can see here, the control group basically always was infected when I went back. Again, the silver product didn't really create consistent results. The iodine was statistically significant, but the copper sulfate was fantastic. And I think those results were heavily skewed by one horse who lost a shoe, and I wasn't given a phone call. And so it went about 4 weeks without a shoe on, sorry, and the patch came out. So that did become reinfected because it was back in the environment where the bacteria was. Horse number 12 was a bit of an interesting one in that it started in the control group, and the in the thesis I'd set rules for myself so that if you're going to effectively experiment, if you have a negative result, I wasn't going to permit that to occur for more than 3 visits because I could not be seen to actually do harm. So this horse went through the control group, was getting worse and worse. We then went to the silver treatment, which was, it got worse, then it got better, and then it was back again, the infection side of things. Then we put it onto the copper sulfate, and the results were really effective. Now, the reason it appears to stop in midair was that obviously I actually had to submit my thesis at some point. That horse went on to have solid feet at the end of it because I did carry on the treatment for all those that were being successful. And I have to say everything that was in the different groups all went into the copper at the end and cleared them up an awful lot faster. This little guy, same horse, it was interesting because although we cleared the foot up, and funnily enough, I actually shot him again today, he's an old boy now, he has a permanent defect where it almost appears to be one tubule does not grow. So I can have his foot solid and there will be a pinprick mark where there is a void, and you can literally, I've taken a pin and you can slide that pin up. Now we can keep it clean, and most of the time it seems to be all right. If his feet get a little bit long, it will become reinfected. So it seems to be, although I can clear the infection, that defect is still there all the time. He's not shot behind now. So we've got a permanent risk of reinfection, but the owner knows about it and we manage it quite appropriately. Horse 16, I wanted to show that actually the point of view of the good management does work, but at what cost? So she was a little horse that the owner kindly changed her world upside down. The horse became permanently stabled. It had restricted turnout. It only went out in the dry. Antibac was put on it, I think, once or twice daily. It was so well managed, it was unreal. Unfortunately, it cost her an awful lot of money and there was a lot of time, and it still didn't actually have a quicker result than we would have done with the copper sulfate. So here there's a little bit of her data, and as you can see, even with the best of treatment, there was still visible infection. It may only have been a scratch of the knife, but it was still there. This is her feet. As you can see, the reason she went into a control group was because I think this was possibly the second visit. The first one we had a pinprick of blood, and the one thing I did say was anything that's got blood involvement, I'm not covering it, because I'm not going to create a bigger problem, or I'm going to try very hard not to create a bigger problem. So the study results showed that the copper sulfate was significant. The various tests showed that it wasn't actually the patch making the difference. So putting a patch on with no medication underneath was going to be no better than a control group. In fact, I didn't study it because I wasn't going to do that, but I would surmise it would probably actually be worse. The application of the iodine or the copper was significant, and because there was no reinfection, you didn't cut any more horn off, the feet recovered quickly. It was all very logical, and in reality quite simple. The hairline distance was obviously significant on the groups that showed the best prevention of reinfection, but it also depends on how fast an individual horse grows its feet. So I came to the conclusion that the reinfection rates were the ones that told me I was actually onto something that worked. So the conclusions from it. So type 1 KDZA poses a risk to the strength and integrity of the hoof capsule. If it's extensive, it can cause lameness and it can be a challenge for the farrier. If it's treated in a proactive method, even extensive areas of compromised hoof can be restored by using a topical treatment. My choice is the copper sulfate under a thermoplastic filler. I choose that because of easiness of application and the fact that when the plastic's wet, the copper sulfate sticks really nicely to it, so you're very in control of where it's going and there's no risk of it blowing around. And once you've reduced the reinfection, you're fundamentally waiting for the hoof capsule to grow out. And I don't require an owner to manage it, which even the best ones were struggling. So this little case, I said I'd talk about him at the beginning. I showed his feet. I was asked to come and see this horse at the vet's. He was lame. He's a little 14-2-ish, little racing whippet, as I tend to refer to him. And on this day, he was most definitely not racing and looking very, very sorry for himself and pretty lame on the sort of 4. And as you can see, there's a whole lot of things wrong with this. But our approach at this point was to get rid of everything that was on the bottom of his foot. This had been a gravel run. Historically, sorry, he'd been unshod. He had started to get a gravel run, I would surmise due to imbalance. The gravel run got so bad he got sore on that, so then the gravel run was opened up, the shoe was put on, and it was filled with glue. The result of stripping everything off, you'll excuse the quality of the picture, we stripped the shoes off, we trimmed him up, we did another walk and trot up at that, and he improved but was not sound. But to be fair, I would anticipate a degree of bruising in behind the wall anyway. So having cleaned the foot up, debrided everything, we treated him. Another reason I like these patches is the method of producing the area to be filled means that there's no clear shear line for the forces to pop the crack out. It's underhemmed round the edge, but these lugs mean that any force coming through it basically hits the lug and is diverted elsewhere. So I've never found issues with them popping out of the feet. And obviously that's important when you don't want bacteria to work its way back in. So this was the underside. I was looking very much at how he was landing. He did want to land laterally first. So we were looking at balance. We were looking at mechanics around the center part of the foot, back to basics effectively. And you can see here a bit of the plastic and how I'd altered the shoe to try and get a base back underneath where his limb was. Quite an important factor when doing these patches is the plastic does come under the shoe, because again you're sealing your patch from the bottom. It would be no point putting a plaster on a wound but leaving one half open. It doesn't really work. So he progressed quite nicely, and this was his feet not that long ago. In between times, Reg, as he's called, managed to fracture the wing of his pinky bone, but recovered from that. He previously had already damaged a back leg prior to me knowing him and had a stifle issue. But sometimes you meet these horses that are just not going to give up. He's back barefoot. He does road work. She occasionally uses boots if she's doing a lot, but he fundamentally has got good, strong feet. This is back in, that's never been shod, which I'm quite glad about because he's a little toe rag. But he absolutely loves his job, as you can see. And his biggest complaint at the moment is she keeps getting time penalties because he goes around like a bat out of hell. So that to me is a lovely example of how when you respect a hoof capsule and pay attention to what's above it, you can return it to a very healthy functioning structure. And the infection side of things is actually the least difficult bit to deal with if you get everything else right. So the bit that I steered away from for my thesis because there was too many variables, the type 2 cases, the systemic versions. So multiple reasons affect the whole horse, and therefore you're most likely to see forefeet involved. We've got a structure that's compromised, and we've got so many factors affecting it. What we have to work out is how can we influence everything a little bit to get a good result. This obviously is pre-trim. Shoes have been too long, and you can see the conditions it's been living in. It wasn't the nicest of things to turn up to, but sometimes you've got to try and help. So environment, again, going back to what Simon said, it's the biggest effect. And I think now we're probably seeing more of it. We've got rapidly changing conditions. The horn gets stressed because it doesn't know, is it getting saturated or is it drying out? And we can have horses that are going from a bog shoved into a very drying bedding, which will suck the moisture out of them. A bit like if we don't keep our skin moisture content consistent, we'll end up with problems there. We may also be having to get used to extremes being the norm. Maybe climate change is going to actually affect what we see with feet as well. But certainly, I mean, even today, I'm complaining that the sun has now made it too bright for the camera to work properly. But earlier on today, I was throwing a jacket on because it had gone dark and the heavens had opened. So this means that we need the owners on board for proactive management, because otherwise we're not going to get a result. The living environment is a big one. So encouraging owners to ensure the horse has got somewhere to dry to stand. If its general environment is very wet, if you can reduce that a little bit, and preferably somewhere the horse chooses to stand, then it's that little bit of help. Trying to limit the rapid and extreme changes in moisture content. So coming in from the bog into the dry shavings bed. I know there's people listening here who are in very arid environments, but I'm sure I remember from my time traveling, one of the problems that was pointed out was people that were washing their horses all the time. So you're in a hot, arid environment, and then you soak your horse twice a day when you've worked it. That doesn't do the horn any good either. And then trying to use topical and antibacterial treatments to minimize the changes and to prevent bacteria buildup. Now, when I talk about extreme changes, this is probably one of the more extreme ones. These are two horses that we shoot. They are meant to live here. Unfortunately, the one at the front, who is a Highland pony, has decided that if he hasn't got a fence, well, he doesn't have to pay attention. The one at the back on this day learnt that he actually can't swim very well. As you can see, he tried to go diving, but he's not very good at that either. He did make it back to dry land and proceeded to gallop around being absolutely furious. But here we have markers showing out the best of a Highland pony, otherwise known as the hippos. I don't like it when clients wash their horses before you shoe them, but when they do it themselves, not a lot you can do. So anyway, oh, that's not meant to play. There we go. So hygiene practices, trying to get people on side just for basic stable management, trying to keep things clean. Regular topical treatment of any smelly areas around the frogs, sulci, around the white line and unshod horses. For the shod horses, somebody applying things into nail holes can be useful. Again, it's almost at every little help bit moment. No one bit is going to make those feet magically better, but everything might make it be able to cope. and trying to get them to balance out the environment. So in the last week, I've noticed that feet have dried up quite a lot, and I'm telling people, can you get the moisturizer on them? Can we just try and balance this out a little bit? But if we get rain for a fortnight, then I'll be telling them to use a hardener instead. And most folk, when they understand why you're suggesting an application, do get on board. So the nutrition side of things, I'm not a nutritionist. I have a basic understanding of it. I have enough to know that if the basics aren't being done, that I will send somebody to talk to a specialist. But understanding what horn needs and where problems may arise is quite a good starting point. And so that you can red flag comments that your clients say that you think this may actually be causing a problem. So the very basics are understanding the relationship between various essential vitamins and minerals. We've got the fact that we understand biotin's needed. It should be there in most diets, but if it's lacking methionine, then it can't be utilized. Most of the additives now seem to have a better relationship, although you can still buy pure biotin, which you might as well pour it down the drain as far as I'm concerned from that point of view. Quite often excess of something can cause more of an issue. So if you've got excess phosphorus, the body won't absorb calcium the same. And the calcium is needed for horn cell attachment. So all of these things are actually to do with the creation of horn and the strength of the bond between the cells. And if that's not correct, so you're already starting with a weakened structure, then you're putting it in an environment that's not great, with hygiene that's not brilliant, and it's not really surprising that we end up with these issues. We don't tend to have a problem with excess selenium, but it is something that should be aware of. Different countries have different issues because you've got a different environment. As I say, I know enough to know when there's something that flags up what potential issue is with my clients, and then we'll either point them to somebody to really get to the bottom of it or make sensible suggestions to hopefully help. This is a big one that I'm sure you're all on board with: size and body condition. Two things. Horses have got bigger. Their general stature has got bigger. We'll ignore the fat issue for the moment. But the skeletons on top of the feet have got bigger. And the feet don't seem to have got proportionately bigger with them. If we look at warm bloods, we tends to be a large animal on top of not very large feet. So we increase the stress and loading on that horn straight away. Then if we get those larger animals fat, we really are asking a structure to struggle. It's going to struggle. So anything we can do from that point of view of advice, and obviously it's one of those you have to tiptoe a little bit with some people, other people are stern where they respond quite well to. But we are dealing with a different animal than was around in the 1800s when this condition started to be noticed. So I think it is important to stand back and look at the whole thing. And if that is one of the things you're dealing with, bear it in mind every time you handle those feet. Laminitis. This is one that can be, as they were saying in the structural cases, can actually cause laminitis, but actually laminitis can cause systemic seedy toe or allow systemic seedy toe to start. So you've got an easy access point, depending on the environment they're turned out on. Hopefully the balance and horn loading as good as it can be in these cases, because obviously our attention is fully drawn to the problem. Nutrition is quite important because obviously we need these animals to grow back quality horn as well and as fast as possible. And again, the hygiene side of things. It's just one of those, it goes with it. Invariably, it's our secondary issue, but one that with a little bit of attention, we can help minimize the problem from it. So how are we going to deal with these cases? These aren't easy. You can't get rid of the owner on this one. Slow going, requires teamwork. So firstly, you've got to identify why it's there. Have a look around the environment. Simple things like walking into the stable. If it smells of urea, then no doubt the horn is going to be suffering. Have a look at the body condition. Maybe talk to a nutritionist or have the owner talk to a nutritionist. And again, if you can explain why and get them on side as to that we have a grumbling problem that may not bother you at the moment, but if we do a little bit, we can make better for your horse. They tend to come on board. And then every time you're handling those feet, and every time the owner is handling the feet, the action should be positive for hoof health and negative for bacterial presence. So the differences between the two. So we have our type 1 structural cases. You can go in and identify it easily. You should be able to sort it easily once you've identified why it's there. And the owner actually doesn't have to change their practice whatsoever. The type 2 cases, we can identify it. Then we need the owner, possibly a vet, possibly a nutritionalist on board to exactly work out what the cause may be. And then we need owner involvement the whole time to hopefully minimize the negative influences of those pathogens. So our goals for these ones is to be proactive and preventative, preserve the hoof capsule, don't ignore the signs of little issues. If I find feet like this that you can imagine there, you've got that bit of a space between the sole, the white line is almost recessed slightly, and then you've got the wall. Well, rather than putting a shoe on top of that just to allow the dirt back to sit there for the next 6 weeks, do something about it. Put in a positive influence. So whether it's Artimud, that's Stromy's anti-back paste, which I like, or the Keratex Hoof Putty, just something to fill that void rather than mud. If you've got feet that are really falling apart, sometimes giving them a rest with using hoof casts can be beneficial. Just give that horn one less thing to deal with, as in nail holes. And trying to get the owner on board so they can reduce the negative factors. Look at the environment, look at the hygiene, body condition, nutrition, and obviously if we're dealing with laminitis, then that's that whole nother chapter. So donkeys. Again, this is something that always comes up, and the treatment process that I was using with the patch, or use with the patch, works great in the shod foot. What I found is the unshod feet, it works well, the area is quite large. Once you're down to the last ½ inch, you tend to find the patches pop out. So then you're almost back to square one, but you can get an improvement. It's just not satisfactory. I think I would now, if faced with it, I would use a hoof cast and a patch. At the time when I was doing that, I really had the odd hoof cast, but wasn't comfortable with them, and I hadn't really entered into the thought. Donkeys is the one that always comes up because they're prone to it. So they can suffer from both types, but normally it's the type 2. Mules, I have very limited experience with. I met a few in the States, and I have a couple of very little ones here. Don't seem to have the same issues. That will be something that I'm sure, again, as Simon was saying earlier, put your questions in. If somebody has experience with mules, put it in. Do they suffer? Or is their horn more like a horse, therefore less prone? Why a donkey's prone? I seem to be doing the rounds today because I saw this chap today as well. So environment challenges, they're really not designed for the UK, and the ones in Scotland must have been very bad in a past life, but anyway, they're here, and they've got a different horn structure. So going back to our anatomy, when we were talking with Simon, we were talking about where the horn flexes and all the different zones of it. Kind of goes out the window a little bit with donkeys. So that's where they're meant to be. Arid environments. They are perfectly suited for it. Their feet work brilliantly there, and then we do this to them, and it's not really surprising that we start getting issues. So fundamentally different. This was a clipping that I got 10 days ago, and it was I'd actually finished putting this together prior to going on holiday, and these were the last animals I saw before I went. And as I cut the horn off, I went, oh, that's quite useful, because I hope what you can see is very obvious where the tubular horn is, but there's very little difference from the inner layers to the outer layers. There's not a massive change. I would say we're slightly tighter horn tubules on the outside, but it's not the same as the horse's foot. So we talk about our basic differences with donkeys. So we've got a hoof capsule that's more upright. It's a different shape for starters. And the wall thickness is more consistent. So where Simon showed that hoof capsule that he flexed, where you could see the wall had got very thin towards the heels, it doesn't do the same in the donkey's foot. The frog's less prominent, so already we have a structure that is less is not designed to flex and move in the same way. It's more of a stump. It's got a different horn structure, as I was saying, which equates quite well to the different function. There's a study to show it actually has a higher moisture content. Now, that was done in the UK, so is that because it was in the UK, or is it naturally a higher moisture content? Logically, to me, a horn that is meant to be in a drier environment would have a higher internal content to allow it to be pliable, moisture content to allow it to be pliable, but that's a hypothesis, not proven unless there's a study out there, but I haven't looked for it. So because of that higher moisture content, it's more pliant and deformable, but because of its shape, it doesn't move as much as a horse's foot. And also, just as a side note, remember when you're looking at x-rays, the P3 sits deeper in the hoof capsule, so don't all jump up and down and panic that it's sunk. So this was a comparison, same date, one pony, one donkey, and not the best of pictures, stuck on top of my toolbox and grabbed with the phone. But I would say that even looking at that, you can see a change. You can see the graduation. We've got larger horn tubules here in the donkey foot, more evenly spread. You can see them larger on the inner layer here on the horse horn, and out here they're obviously very tight and very small. These are less dense than over here, particularly once you get to this outer layer, and there's less distinct zones. So straight away we have a different structure that the same pathogens are affecting. So how do I approach it with these guys? I've never put a patch on one. I've never treated them like that, mostly because I think the ones I've got, you'd almost have to sedate them because there'd be little toe rags if I got a drill out to do the patch. But the big thing is regular treatment of a topical application. So whatever it is you want to use, whether it's Swan's antibac, and having an owner that's understanding. Its management basically is our biggest goal. If you're trimming, you can apply something, but that's one day out of however many weeks you see them. Interestingly, we used to have a client who had 5 donkeys, lived on top of a hill of Drumnadrocket, which is by Loch Ness, as you can imagine, not exactly dry. However, she had an interesting setup where they had to walk through a footbath and they were in every night. And in that footbath, she had Jay's fluid. They really didn't have an issue. We kept on top of those feet. You'd have the odd little cavity, probably maybe that a little bit bigger on just one part, and we could keep on top of that. And she was very good using sprays on the feet, and she kept their feet great, which really did show us that good management, but she'd set it up to be easy to manage them. So the conclusions for this is very much we have to be observant. We have to be aware of what's affecting the whole animal. So observe. What's its conformation? How is it moving? Why is the infection where it is? Is it overloaded? Recognize that that's the cause. Okay, it's got a really obvious crack. Bacteria got in there. Why is that crack there? Not just that it's got a crack, but why is the crack there? What's the mechanical problem that's allowed a crack, which has allowed an infection? Is it type 1 or is it type 2? Has this horse got a problem that means all its feet are compromised? Has it got one issue, one foot that we can deal with easily? So then look at the treatment. As I say, the structural cases now are really quite straightforward. Remove the cause of the weakness, deal with the infection, the foot will grow out. Do not take your eye off the ball for why the cause started in the first place. I have had cases where I have helped other farriers deal with the horse. One in particular comes to mind. Hind limb imbalance created excess loading on the outside toe of the hind foot. That infection went all the way to the coronary band and round to the heel, leaving us about ½ an inch at the heel. By sorting the balance, we dealt, and then dealing with the infection, that foot grew out. Horse changed owner, different farrier. I got a call about 3 years later and we were back to square one, which I have to say is enough to make me quietly cry. New farrier, on board, sorted. So it was just sad to see it reoccur, but everybody then learned from it. Management, again, talk to the owners, get them on board. They will, for the type 2 cases, they will make or break it for you. They'll keep them right. You can just deal with the type 1s on your own. And they're normally delighted when you say you don't have to do anything and you can just carry on as usual. They're really chuffed with that. And then prevention, again, preserving hoof wall, respect what an incredible structure it is on the end of the horse's limb, and make sure it's in the best condition as it can be to carry out its purpose. And hopefully that's about right timing. Thank you very much. I'm sort of coming in and out of light, and I'm presuming Simon is somewhere around.
Of course I am. I never left you, Sarah.
That's all right.
Hanging on every single word. So that was great. We've had a few questions come in, and I've got questions of my own as well. I made a few notes. So that's really good. So thank you for that. I'm sure everybody would agree that the reason you know so much about this debilitating problem with hooves because of all the work you put in and studied it in a scientific manner. But the great thing is that you've shared it. When we come, when you get your recorded version and papers, there will be a link so that you can get Sarah's Worshipful Company of Farriers Fellowship thesis. It's there for all of you to download for free, which is a great innovation that's come about in the last few years, where all the theses are available. So thank you once again, Sarah. Do not go away, because we're going to have quite a lot of questions in I don't know, 40 minutes or so. But I'll just see what I've got next. I know we've had a winner. Sorry, we've had a winner of the scavenger hunt, and that winner is Laura Welsh. Well done, Laura. As you probably remember, I showed an inkwell made out of a hoof specimen, a little bit morbid, I know. Actually, Laura found exactly the same thing. I went and had to go and check that she hadn't stolen my one, but almost identical. Of course, it was an old Victorian thing where beloved horses were, once had passed away, they were turned into inkwells and things like that. Doorstops, I think I would prefer. But anyway, well done, Laura. So now we come to the questions. Sarah, you're not allowed to enter this. And we've got 3 questions here, and really they're based on Sarah's presentation. Usual rules apply. First one to get the 3 correct answers in is the winner. It's another fabulously valuable book that is the prize. So let's see what we've got. Question 1. Which element of horn is digested by the fungus? What section of the hoof wall is affected by paralytic disease of the zona alba? And is type 1 paralytic disease of the zona alba systemic or structural? All those answers were given to you by Sarah only minutes ago. So those that are not busily writing the answers and sending in, please enjoy a break. We've now got a shortish break of about 10 or so minutes, and then we'll come back and I'll do my presentation. Thank you very much again, Sarah.
Thank you.
Right, let's be getting on. We're just still working out who has won this quiz, but there's been lots of answers come in, so I'm leaving that to Sophie sorts that one out. Just to remind you that if you want to get a free copy of the Farriers Journal, email Sophie. There's a couple of conditions that won't cost you any money, but please do that. So we're going to be looking at other things that go wrong with the hoof capsule, staying away from paralytic disease of the zona alba. I did love it that in the answers, one guy did use the term saying it was the white line that got infected. So much for me trying to convince people that the white line and Sarah as well, is not the structure that gets infected. But there we go. So we're going to be looking at other things that go wrong with the Hoof capsule. So it's really an overview because it's very difficult to go into detail. So we're going to look at the Hoof capsule, its functions. We've looked at those earlier. We're going to look at microbial invasion, nutrition, and external factors. I'm probably not going to go into keratomatous growth. All right, well, Sarah has covered seedy toe or cherolytic disease of the zona alba really well. And there's a couple of examples there, very simple. Sarah was talking about cracks and how behind them this horn-eating microbes and pathogens get in there and attack. And this is another view, which is why it's often us who are the first people to see this structural damage. So a nice big hollow hoof there. Of course, seedy toe is often said to be involved post-laminitis, so in chronic founder cases, and you can see this is a horse who has survived quite a severe attack of laminitis, but has it's got this distended white line. And I think there are pockets of infection that get in there, but we can even see the lamellae here. So it's been very distended and stretched open, and therefore created cavities, which does allow for some types of horn-eating microbes to get in there. Okay, hoof wall separation disease. It used to be called hoof wall separation syndrome, and I have only just changed my term for it. The reason for that is it's recognised as a more specific disease now, and it is genetic weakness. I've had some people say that it can only be in Connemara ponies because it is a genetic weakness that's recognised in the Connemara ponies, and you can see this is very typical of where about half to 2/3 of the way down the hoof wall, there is this separation, and that separation would again appear to be across around the zona alba, and the whole hoof comes away and disintegrates. I put it out on Facebook leading up to this webinar, just to get the view of a lot of people. One of the great things about Facebook, and just like everybody else, I'm a skeptic of it, but one of the, or I should say I'm a cynic with regard to Facebook. One of the great things is you're able to contact so many people all around the world. So I asked about evidence of other breeds, and lots of photographs came in. It was very good of many people who sent them in, and it sort of confirmed to me what I believed, was that it's not exclusive to Connemaras. Here's a very similar breakaway. In fact, part of the reason you can't see it here is because it's been repaired here. So we can see that there is cornified tissue underneath where it's split away. And so I think it's at least at this level, at the zona alba level. In fact, of course, you can see just how unpigmented all this is. So it's a difficult one to deal with, because the problem is, since it's a permanent lesion to the hoof, a permanent condition, that yes, we can repair it because we have such good acrylics now, and we can repair it. And if we do a really good repair, it will stay there for possibly up to several months. But the thing is that has to be repeated the rest of the horse's life. So one would hope that the fact that Connemaras are being tested genetically and are being excluded from the gene pool if they have this, and undoubtedly in a number of generations, it should be that perhaps the Connemara will end up having the best quality hooves in the equine world, and the other breeds which don't test for it and don't seem to think it's a problem may well end up having far worse problems. But I just wanted to put that in, that I don't believe that it is just Connemaras that have this problem. And as I say, from just doing an anecdotal survey through Facebook, a lot of you sent in lots of examples of non-Connemaras with what is clearly hoof wall separation disease. So one thing I wanted to point out, we can see this very nice preserved specimen where a distal phalanx has been, a whole distal phalanx has still been left attached, although the hoof is through a sagittal section. But it allows us to think about the hoof wall and the stresses on it and where it's connected. I think we sometimes imagine, when we look at a healthy hoof wall from the outside, we imagine that it's connected right the way down to the bottom to the lamellae. But of course, the lamellae connection stops at the distal phalanx. So the strongest connection of the hoof wall is between here and here. After this point, there is far less connection. I know that it's connected to the sole by the white line, but there's not that strong semi-rigid connection that you get. And therefore, if there's stress on this hoof capsule, it's at this point that it will pull away. And so I think, obviously, the lamellae by this point have gone, and we just have the hoof wall and the white line, and it's quite easy for it to break at that point. Okay, let's have a look at infections that get into other parts and not just the hoof wall. The most obvious one, of course, is thrush, and you can see that it's considered to be Fusobacterium necrophorum, but I believe that's a whole group of bacteria that goes into that, and so it's still not that specific. But this is very typical of thrush attacking the central sulci, and of course, in bad cases, we get thrush in the lateral sulci as well. And we're going to go on to canker. But of course, the thing that is important about thrush is that although canker is very rare, it undoubtedly gains access through a thrushy frog. That does seem to be the precursor to canker. So we need to take thrush seriously. I'm always stunned by the number of horses that are very good horses, and yet owners allow them to have thrush. Now let's make this clear. No hoof care specialist, whether it's a farrier or a barefoot trimmer, ever caused thrush. Our only job really is to tidy up the sides and allow the regular treatment to get rid of it. And thrush is really, really very easy to treat. So I'm going to look at this video here. I have a feeling we're not going to get sound on it, but I have absolutely no reason understanding why we haven't. Let me just get rid of that. So we can see this hoof. It's not a great quality hoof, and it's quite narrow. If anything in life, it looked even narrower than this. But the point I'm making here is that although it had already been treated for thrush, you can see how the heels were shearing and how it was quite easy to move this hoof. And if we put that tongue depressor in there, you can see how deep this crevice is, as I say, despite being treated. So I was asked to treat this and get rid of it. And this horse was lame. And although some people might say often horses don't go lame through thrush, although it might lead on to something else, I think this horse was lame because of how unstable the hoof was. And one of the ways to give stability is to have a healthy frog. But we do some do some more on it. And now, of course, the first thing to do with any thrushy frog is to trim it. And so we trim it, we can see what's healthy and what isn't. We can get rid of any flaps going down the sides, and we can open up that central sulci a little bit, and then that allows treatment. I'm going to move on. Actually, I think, yeah. So nicely cleaned up, and you can see the central sulci is also open. Now, with this horse, I always used to use the purple spray, antibacterial spray, but that's harder to get hold of now. And I think there's a couple of other topical treatments you can use. In fact, there's an awful lot about now. I would agree with Sarah on the copper sulfate. I've been a great user of silver feet, but with copper sulfate mixed into it. But at this yard, because it was just, I took the opportunity to do a video, we had to use what we could lay our hands on, and we had dilute iodine, so pevidine, and we had some hydrogen peroxide. So I'm going to put the hydrogen peroxide in. You have to be careful of your eyes. This is the easiest way with a big syringe. I would say horses do really feel this, because it is something of an astringent, and you'll see what this horse does, I think. There we go. It just gives a little jerk because he doesn't like that much. So you have to know your horse and be careful, but we've got plenty in there. I was once told that, of course, you shouldn't use hydrogen peroxide because it kills a layer of cells. Yes, it kills one very fine layer of cells, and it kills all the bacteria. So it's quite useful. And then if we go on having treated it with the peroxide, and now I'm going to use the dilute iodine, pevidine, again, not something you want to get in your eyes or in any wounds in you, but it's more effective dilute. And then the real trick, and I'd have to say this is always the real trick, is to use cotton wool. At this yard, we only had the cotton wool pads. I prefer, the fluffy open cotton wool. You shouldn't be worried about how much you can tuck in there. They are never going to, the frog is not going to heal over the cotton wool. So tuck plenty of cotton wool in. I think it does a couple of things. It keeps more debris and mud and feces out, but it also keeps it open, and therefore more oxygen gets in. And just like most of these problems with horn destroying microbes, they are anaerobic. So I'm going to put a bar shoe on, and that might look round and short, but in fact, by the time the foot's trimmed, and you can see it's a very oval shape, it was quite a nice fit. And let's move on to that. So this is it with the bar shoe on. And really, what I'm trying to show here is that what have we achieved? We've treated this in more than one way. We've trimmed the frog, we've plugged the frog, treated it with antibiotics, and now the shoe, you can see how rigid it's making the foot. So we often think about hoof flexing for health, but in fact this hoof was flexing far too much, and in fact it was sound the next day, and it had been lame for 2 weeks. So I think it clearly was the case that it was that the hoof was unstable and it needed more rigidity. The picture on the right is one that was a picture taken 6 months later of that same foot. Still got fairly poor quality hoof wool, but as you can see, the frog is in absolutely excellent condition. I don't think there's any excuse really to have thrush in any horse's foot. I think even the most severe cases of thrush you can usually get rid of in a couple of weeks. For milder cases, you would get rid of just in 1 week. So let's move on to canker. It does come in many forms. Most textbooks describe it as the way you see it on the left, and they often say it's like cauliflower. I would have to say that description has put me off the vegetable cauliflower for most of my life, and I don't know who of you cook cauliflower and it comes out looking like that. But I get the description that it is this extreme growth, and of course it used to be thought that this was the growth was on the frog, as opposed to it is the frog has been overstimulated to grow in this peculiar way. As I say, doesn't always take the same form. Sometimes it's quite yellow and smooth, almost like the top of a mushroom, and I've certainly seen that. Canker does tend to appear far more in hot tropical countries, and I went and spoke to my friend Bernard Duvernay, who has lots of experience in India, and asked him what they did, and I'll come to that in a few slides. So this picture was sent to me by Liz McKillicuddy, who's a vet, probably an hour's drive from here, and she showed the successful treatment of canker, and here we can see this horse. I think the canker was removed surgically as much as possible, and then it was treated with an astringent. And canker can be successfully treated. The only word of warning is that sometimes it is frustratingly difficult to treat, and so I would never ever promise a client that you'll get rid of it. You can see a horse here that I was working on. This is my bald head, and this is Declan Cronin, who often attends these webinars. He is based in America, but travels quite a bit, and this was at Rossdale's at the operating theatre there at Rossdale's Equine Hospital. And actually this horse had canker in all 4 feet, and we made 4 hospital plates for it and fitted them. We were going round behind the surgeon who was operating on one foot as we were nailing on to the previous foot, and it was quite an experience. 3 of us farriers. I know this is only the back of him, but this is Aaron Gigax from Switzerland, who I will be seeing this September. I don't know if any of the rest of you are going to go to the Farrier Jam that him and Alex Werner are putting on. And the reason I look like I'm braying like a donkey is they had just pointed out that they've got a good picture of my bald head. But so we had some very serious work going on, but that doesn't mean we weren't enjoying ourselves as well. And there we can see this hospital plate, which is open at the back because of how far it needed to come up the frog. This is the plate on the other foot, and so we made 4 of these open shoes with almost donkeyed heels and then bent up, and by that manner we were able to attach it. This was it, I believe, about a week later, so you can see where it had been removed surgically and treated with an astringent, and actually it was very successful considering how bad it was. So as I say, I had a chat with Bernard Duvernay because of his experience there, but I wanted to put a list of these up, and you've already seen me using for thrush hydrogen peroxide, and we have to remember that is an antiseptic. We have to take care with it, both with our eyes, and we have to remember that the horse will react as that horse did react by jerking away a little bit. Iodine solution, or Pevidine, is an antiseptic, so it does have a great microbial effect. And in fact, for most infections, abscess types, that's always my go-to treatment. I love iodine solution. I think it's the best thing for killing as many bugs as possible. So often though used on canker is metronidazole, which is an antibiotic. I've always had difficulty saying that name. Is sometimes used actually on paralytic disease of the zona alba in the way that Sarah was showing. Lotigen, which is an astringent, and you can see a tube of it there getting well used. Sorry, no, that's the Betnovate. Lotigen is an astringent, so that dries tissue and pulls it together. And I know that from what Bernard said, they use that a lot in India. And of course, and Betnovate is a corticosteroid. Sorry. I'm not a veterinary surgeon. You need veterinary involvement to be using these. In fact, you must have veterinary involvement if you have canker. Really, if as a farrier, you shouldn't be just going ahead with these with condition as severe as this on your own. And as you can see, it involves surgery, and we certainly should not be involving ourselves in surgery. But it's well worth having some background knowledge. So in basic terms, although some people say that you can use these without removing the fairly obvious cankerous growth, in fact, you would need to get closer to the base tissue, I think, to have a good result. Very difficult canker, but as I say, I have seen some really very good results. So allied to canker is pemphigus. Now, I know on Facebook when we put something out, there was a comment, and I hope that person is attending this, saying that pemphigus and canker are not the same thing. I don't think we ever said they were the same thing, and they're certainly not. Pemphigus is an autoimmune disorder. So in other words, it is the body attacking itself. And the type that we have associated with canker is generally a benign variety called pemphigus folicaceus. I think the other type is pemphigus vulgaris, which is a name that I really love, but I can't say that's what we have here. So pemphigus, I think, is because the canker is so damaging to the tissue, it has, in real layman's terms, confused the body, and the body starts to attack itself, trying to defend itself from canker. So no, they are not the same thing, but that one canker often leads to a pemphigus reaction. And of course, one of the things that we see has an old term, choroiditis, or it's coronary band dystrophy, and that I think is clearly a pemphigus. You can probably see this redness here. If you try and rub this off, you will often go down to bare tissue. So it's a reaction of horn-producing area, germinative area, and it's producing this very this exuberant but chalky and poor quality horn. And we sometimes see it involved where we see some of these very contracted feet, and you can see this looks wet around the edges, and that also would appear to be pemphigus. Let me just, okay. So I've often heard said that there's canker also in the ergots and in the chestnuts, and this is canker. I'm not 100% sure if it is canker. It is the same leg as this horse. I think this is another example of pemphigus because the pemphigus is this autoimmune disorder. It is also causing problems at other horny areas. And we can see here fairly typical of pemphigus is where the hair is standing up here at the coronary band, at the hairline, at the bulbs. So treatment consists of long-term glucocorticoids, and I'm not even going to try and say that one. This is why you need veterinary surgeons involved. But it is possible to treat pemphigus. I would say if it's involved in canker, you need to be treating the canker, otherwise the pemphigus is just going to return. And also diets of omega fatty acid and vitamin E supplementation. Apparently that will often help. Sunlight restriction, which I would have to say is something that just slightly surprised me, but again, it's given as a treatment for pemphigus. And of course, as I said earlier, addressing the causative factors. So we need to get rid of the canker if we're going to work on this pemphigus. I wanted to put lymphangitis in because you might say, well, is that an infection of the horn? It certainly isn't, but it is an infection that set off the lymphangitis initially, and it's had this, well, we can see just how poorly this leg is, how swollen, how full of the lymphatic fluid, and of course here we can see where it's broken through and it's just weeping down the leg. And I knew this horse, and it was like this for months. In fact, I think a couple of years. And the only thing that could be done for it was some exercise which would bring this down, because it would help the lymphatic system work. But the reason I've put it in is that the infection up here causing this lymphangitis has had a secondary effect on the hoof. We look at the hoof, the other hind leg, the right hind, we can see that though it's flattened off a little bit because of continual overloading, in fact, it's a relatively healthy horn, no cracks or blemishes in it. And yet, if we come to this side, we can see just this peculiar poor quality horn that's being grown by this hoof because it's being badly affected by the lymphangitis, and that's affecting the pattern of growth. So let's have a look at keratoma. When I decided to do this webinar on the subject, and I thought we were mainly aiming at infections and microbial infections, and of course a keratoma is not a microbial infection, but it is a very unusual growth within the horn. So I thought, well, we'll have a look at keratoma, and we can see a still CAT scan of a cavity in the distal phalanx caused by a keratoma. Here we can see solear keratoma, and this is it here. This is in centimeters, so it's certainly nearly 4 centimeters wide, which makes it over 1.5 inches wide. So that's pretty big, and it's just in the hind foot of an Arabian, so not in a particularly big foot, a really big cavity, and it went all the way down to the distal phalanx there at the wing of the pedal bone. This is again this is an MRI showing 2 keratoma, one that is impinging on the distal phalanx and this one that isn't. And with the advent of MRIs, we're able to see an awful lot more keratoma than we thought existed before. So a keratoma is an aberrant, in other words, it shouldn't be there, hyperplastic keratin mass. So it's growing this horn that's not particularly organized, doesn't have particular strength, but it's growing a lot of it. It can be described as a benign tumor. In other words, it doesn't spread to other parts of the body, but the problem with a keratoma of the hoof wall or of the sole, they seem to get bigger and bigger and bigger until they start causing problems to the distal phalanx, impinging on that, and this a cylindrical keratoma pushing in on the hoof wall. So we looked at those, and those were little spherical ones. They seem to be far more common than the cylindrical, and nowadays there are a lot found in hooves when other things are being looked for. So they are more common. I think in most cases they don't cause problems, because when they get bigger and bigger, then we do get a problem. And we can see a couple of cases here where the hoof has been trimmed, and you can almost see this horn structure here like an onion. It doesn't show up quite so much on these two, but it does. You can clearly see it if you're trimming the foot, that there is something unusual going on in there. So it's often whoever's trimming the horse that sees it first, unless it's got so big that there's an infection or there is irritation to bone. So how do we know it is a keratoma rather than an infection? Well, one of the things that's often said about a keratoma is just how smooth a cavity it causes in a distal phalanx. And so you might say, well, is that one smooth? But if we have another view of this here, we can see that there is an infection there that's caused that's gone all the way through the distal phalanx and has come out at the top there and is causing remodeling of bone right the way along the parietal surface of the distal phalanx. But it's still true that the easiest way to see radiographically if it's a tumour is by that smooth outline. So I had this case many years ago, and because I was fortunate enough to be attached to a big equine hospital for 25 years, so we saw things that other people were less likely to see. This was referred down 100 miles further north the Newmarket. And of course, at that time, most farriers, if you said, have you seen a keratoma, they would say, I've never seen one, or I've seen one, or maybe I've seen two. So my bragging rights were that in a single foot, I saw 3. So there was a decision made to remove them because this horse was lame. It was fortunate it was a hind foot, but to remove them. And so in preparation, I made a hospital plate shoe with a visor at the front, and I was going to nail it on the operating table. Unfortunately, when the operation took place, far more hoof was removed. And so this might look a real messy glue job. But when you're on the operating table and you're told you've got 5 minutes to glue it on, you don't really go for aesthetics. So this is it. You can see where, should we say, the previous outline of the foot would have been, and this much hoof has been removed and this much bone. So we got an x-ray of it, and so this is the same bone. We can still see the smooth outline there, just how much it was taken back. And we can see another view of this. So we were able to pack this every day with Pevidine soap swabs, and this visor here, which had a slot so you could really adjust it, the pressure into the wound, which really helped the healing and helped protect it. This is it a number of months later. I would have to say that we were stunned how well this healed. So it was a really a great experience, and that's probably, well, certainly 15 years ago, it might be 20 years ago in my career that I did this. We can see that there is still tissue exposed, so we were still using this shoe and protecting it. And this is the hoof. There's just a little area left there. And it looked a little bit almost like a chronic founder, where it really wanted to grow heel. It had to be rebalanced at each stage. But you can see healthy frog, healthy sole. There's two things about this. It had a problem growing really good sole here. It did have a covering, but this was not the best quality sole. The other thing is this is really unpigmented horn here. So it stopped producing pigmented horn. As you can see, all this sole is pigmented, and it produced just in unpigmented, exactly where this hoof was removed. But nevertheless, 9 months post-surgery, this was a ridden, successful, happy horse with a very happy owner, even though it had that much distal phalanx removed. Of course, the fortunate thing was that it was a hind foot, so not loading as much as a front. Just look again that this is clearly made by a spherical keratoma, and here a cylindrical one going right from the germinative area up in the coronary band, and this of course is lodged usually in the sole actually. This is that case that I just showed, and this was it. Only I think a month or 6 weeks later, cornified over very, very quickly. So first the dermis, well I should say first the subcutaneous tissue, when it's this deep, it regenerates, and then that generates the dermis, and the dermis generates the epidermis. So of course, although abscesses themselves are infections of the dermis, they affect the epidermis outside because they're destroying the attachment. And submural, as I think most of us who have experienced that, if you think a subsolar abscess will make the horse lame, submural will make them absolute fracture lame. And usually the infection will run up a row of lamellae and burst out the coronary band, although at this point you can see the pus there, so it was got at before it got all the way to the top. I just wanted to show sequestrum removal again because it's really the healing, the epidermal healing that I want to get over. Not quite so easy to see the fracture or the little sequestrum there. You probably now see it. There it is, a loose piece of bone with infection all the way around, and we can see that track traveling up there. A little bit of a messy operation maybe. It was standing surgery. It was a veterinary friend of mine who had his own stud farm, and so this operation was carried out in the barn, and it was removed. And when I saw the horse a number of months later, much as this is now due for shoeing, we can see that actually healing is pretty good. So as long as we remove the object that's causing the infection and keep it clean, we will get good healing. So just to remind you of what this lecture was about, we looked at the functions in the first lecture, but all of these types of infections impair the function of horn. In other words, any loss of function by just disease in one part affects it all. So it's really important. Even the, shall we say, the boring old thrush. Thrush is very easy to treat, and it should be treated. We looked at microbial invasion, and that's been mainly what today has been about, this webinar. And I hope I discussed keratomatous growths, and we looked at really the connective region and going into the dermis. So even a crack like this, which initially is just a problem of the epidermis, eventually will affect the dermis, and that in turn will then attack the connective tissue and make regeneration more difficult. Just before I do my take-home message, I would say on Facebook somebody was very funny because they pointed out that this picture here looks like some sort of angry frog or toad or turtle, and so I hadn't even spotted that when I put the picture up. But well done. It is I don't know. Maybe it's a toad, not a frog. That one. Okay. So the take-home message really is that the hoof is extremely good at fulfilling its required functions. I think when we see webinars like this and we obviously we focus on the interesting things, which when things go really badly wrong for the hoof. But we have to remember that for most horses, actually the hoof is an extraordinary organ and does its job very well. Highly adapted integument for an extraordinary animal, and it does it very well. But nevertheless, occasionally it needs our help. And you've seen just a few tips of how I think some of these things can be overcome, and you saw some great stuff from Sarah. So now we come to the questions and what the answers were, and we do have a winner. But before I tell you who that is, the question was, which element of the horn is digested by the fungus? And the answer to that is keratin is what is digested. That was the answer that was being looked for. Question 2, what section of the hoof wall is affected by keralytic disease of the zona alba? I think I've gone and pushed the answer across to here. Is the zona alba is affected. In question 3, is type 1 keralytic disease of the zona alba systemic or structural? And of course, Sarah spent a lot of time answering that, and it was structural. So the person that, there was a number of you got that right, and lots of you got 2 out of 3 right. But the first person who sent one in that got all of them right was Yvonne Lucius. And so well done, Yvonne. Your prize will at some point be winging its way to you. You can come on board, Sarah. We're at the end. I saw you pop up at some point.
I'll come out of the dark.
That's right. So we're just gonna, there we go. That's us there somewhere. And so I've already shown our partners, so thank you to our partners, because I want us to move on. But just to tell you that our next webinar, we haven't got the date yet. We've got some really exciting plans, but our next webinar will be in September. We're going to have a really good summer break, recharge the batteries, let you enjoy the summer, and then we're going to be back. Anytime you want to email, please email sjcurtisbooks@gmail.com. You will get Sophie, but if it's something that I have to answer, she gets on my case straight away to answer you. And just to remind you that we really do appreciate your input. So what we're going to do now is do question and answers, and I can see that there's 10 there, and I've also got a couple of supplementary ones which have been emailed in, and failing all that, I've got a couple of my own, but I'm not sure if we're going to get there. We're going to go from the top, Sarah, and we'll see what this says. Okay, would you not consider the periopal equivalent to our own nail cuticle? Would you consider that, Sarah?
It's not a bad analogy. Yes, it's covering the gap. Yeah.
I just forgot to say that. So Patrick, yes, that's what both Sarah and I would consider. Now, Brandon has come in with a couple of questions, I think, and it says, Dr. Curtis, could you speak more on the basement membrane, BM or BL? Is it included in the stratum germanavatum or germanativatum? Some textbooks have described the basement membrane as the line between dermal and epidermal structures, but there are living cells outside the basement membrane within the stratum germanavatum. Could you explain, please? I only wish I could, but I tell you something, that's a very technical anatomical question, and I during the break went and had a look at one of my Pollitt books, because Pollitt is the man to go to, and clearly I think the basement membrane is part of the stratum germanavatum. I'm still not sure if that's spelt right, but anyway, it might be my pronunciation that's wrong, because clearly that's where the cells are germinated from. So it is part of it. The other part about is there sometimes live tissue outside of it? I assume you mean within the horn I know Pollitt often used to show where an attacker laminitis where the lamellae are stretched and there's islands still functioning. So if that's what you mean, that's the best understanding I have. I don't know what you think about that, Sarah.
Yeah, beyond what you've said there from Pollitt's views on things, nothing further to add, to be honest. Yeah, I would consider it part of the same thing. And as you say, the islands would be the only time I can think that would actually occur.
Okay, well, I hope that helps you a little bit, Brandon. We've got Joan who says, seedy toe under glue-ons, composite shoes. Do you see it more often than on standard shoes?
I probably don't use enough glue-on or composite shoes to be able to compare. My thought would be if your preparation and cleanliness prior to gluing them on isn't top notch, then you are going to lock in bacteria into then an ideal environment for them to thrive. So theoretically, yes, you could, but it would come down to initial application, I think.
Yeah, well, I put on an awful lot of glue shoes, and that would be my answer. That if there's already infection under there, then when you take it off, it will still be there, or there'll be more of it. But if there's not, I don't see it. I would say I think glues do have an awful drawing effect on the hoof, and they definitely weaken it over a period of time. And so, although glue shoes have been a tremendous boon to us over the last 20 years, I think they're still at the point where they should only be used while they have to be used, and then take them off. I think as well that if we're talking about composite shoes, so plastics and polymers, I'm sure the foot sweats against them than it would against steel. I know there's been some people trying copper coated shoes, but I don't know whether that will improve things at all. But it was a good question, and definitely, if you're going to cover the hoof, clean the hoof. I think that's the best thing we can say. So Norb Lawrenson, who is a former mule packer, says, I had a string of 12 mules, 3 of which had cherolytic disease of the zona alba. Mules kept in mud and manure, former packers and farriers dubbed toes aggressively. So in other words, that's how they trimmed them. But I think that, Sarah already made the point that this is a desert animal, a desert horse, the donkey, and so donkeys certainly don't like mud. Mules probably don't like it much, but even horses don't really like it a lot, do they?
But the dubbing of the toe there is the bit that I would go, they've just exposed part of the horn that's not meant to be dealing with the environmental effects. So, and I read somebody else put down with that further down, somebody added to the mule bit, would the dubbing be a potential structural deformity that increases the risk of the infection? Yes, basically.
You got an answer to that, and of course, there's different degrees of dubbing, isn't there? There's just rounding the bottom, half inch, or I don't know. I always get that wrong. 1.5 centimeters, something like that. 1.25. That I think horses that are shoeless ought to be rounded, and then there is dumping, which I think is more, where you're going, I don't know, 25% of the way up the hoof wall and really taking it off, and that's the difference. Just getting the balance right. I think Norb has added another, adding to former. Did not have cherolytic disease of the zona alba in other strings kept in clean environments with non-dub feet. Well, there we go. Although that's not exactly a scientific study, anecdotally, your observation would appear to confirm what Sarah has just said. Don't dub, as you call it, or dump, as we might. Okay, Patrick needs you, Sarah, to answer this. Please detail how you prefer to incorporate copper sulfate into your patches. Do you use different methods for different situations?
If I'm doing a an area that I've debrided, I'm using the thermoplastic granules, and when you're about to apply them, they're wet, and so I very technically dunk it in the copper sulfate powder, which means that it then goes into the area I've cut out and covers the surface. And when it's clear, you can actually see that you've now got a nice blue covering, so you know you've got everywhere. Lesser areas where I'm not debriding, I will either mix it with hoof putty, or I had one the other day that, because of the situation I was in, wasn't safe to debride it. But I took out as much as I could from underneath, literally poured the copper sulfate powder in, and then plugged it in, and there was a shoe on top of that. So with that, I was actually trying to see, because of behavioral issues, I wasn't going to get my head kicked in trying to drill into feet. So we were going for a safe theory of, will this work? So it's a little bit of an experiment. But my theory is, if that powder's in there, one of the things I will add that I didn't say earlier, do not use it near sensitive tissue, because they might react to hydrogen peroxide. They really react to copper sulfate, and you will have a serious issue. But careful fertling, clearing a cavity, pouring it in and putting a hoof putty on top is another option. And what you'll find is the copper sulfate will leach through the horn to a degree. Yes, a bit like the other treatments, it will kill a layer of horn, but then effectively you've got a layer of poisoned food stuff. If there is bacteria and fungus there, never mind the fact the copper will destroy their cells anyway. So yeah, slightly different treatments depending on the situation, all with the same theory of get it as clean as I can and have the copper sulfate covering the layer that is likely to be reinfected. Because with these cases where you've got a bigger area, the infection's not going to start in the middle of the area you cut out. It goes around the periphery. So it's that's the area that's most important, to make sure you've got a good layer of copper sulfate in there. It doesn't need to be an awful lot. It's very, very potent stuff. It needs to be used with respect, but it does work very well.
Okay, thanks, Sarah. Next question was copper sulfate in the white line. Joan, I think you mean in the zona alba. I think we've decided the white line might get stretched a bit, but it doesn't tend to get infected. Under the shoe, any tips to make it stick or stay longer there?
And mixing it with a putty or a paste. I should have added to the last one. If anybody wants the how-to leaflets on what I do, I've got a step-by-step one on my website, which is just sarahlogiefwcf.com. So you can actually look at a leaflet and it shows you step-by-step. But yes, underneath a shoe, I would just put it, as I covered in my presentation, using a paste or a putty. You can put it underneath that, and again, it will stay there for the period of the shoeing.
Okay, and if you can make sure we get that to Sophie as well, that link.
Okay.
When all the literature goes out, people can just click on and get you there. I would say about the copper sulfate, well, in the zona alba under the shoe. Firstly, if there's a shoe there, it doesn't tend to come out. Nothing comes out. But if you mentioned earlier about a shoeless horse, Sarah, and I would say use acrylic. Copper sulfate will leach through acrylic. At least you know with acrylic. I mean, I know your preference is the thermoplastic imprint granules, but there is no doubt that acrylic sticks better.
There's guys in America that have used both and used the copper sulfate underneath. My preference is purely because it's really easy and I don't get nearly as messy. And I'm good at getting messy. Yeah. But I know guys in the States have used my method, but swapped to use Equilox and found that worked really well. So yeah, the material is less important than the treatment underneath it.
Now, it's Patrick who's obviously looking to set up a canker clinic, because he says, could you ballpark the total cost of treating the canker case? Do you know what? I haven't a clue, because it was certainly a serious insurance case, but I would imagine our treatment alone was £1,000 or £2,000. So you can say $2,500 or something. You know, four hospital plate shoes. And much as we were having fun, and it was a great thing to be part of, and all farriers fancy themselves as a surgeon, so they love getting greens on and getting in an operating theatre. nevertheless, we have to earn a living, so that was the sort of price it would have cost. But I don't know, with the care at the hospital, although it did go home after that first week, it still comes to a horrendous amount. Now, let's see, I think I've jumped up there. Where are we? What concentration of hydrogen peroxide do you use for thrush treatment? Off the top of my head, I think it's 5%. Does it often it either comes as 5 or 10%, I think.
I was going to say 10, but
yeah, maybe 10, but don't go above that.
No,
it isn't just. I mean, obviously it fizzes, and I can see the foot exploding. No, I'm joking that bit, but I mean, it does. That's one of the things that it's supposed to be doing. It just flushes it out because it's fizzing. Okay. Could you go over? Noel says, could you go over again how the cavity is created in the bone when there is a keratoma? Well, the simple thing is there's just consistent pressure there, and so the bone remodels. It's just the body is moving bone away because of the pressure, but since the keratoma is growing and it just keeps doing that, it's the body that removes the bone in response to the keratoma. I think it's as simple as that. I don't know if you have anything to add, Sarah.
No, I would go with that. It's the pressure.
All right, I've recently started using field paste for fungal infections. I've had amazing results. Has anybody else used this product? Well, I'm assuming it's called field paste. Have you ever heard of that?
Red Horse do a field paste that's good.
That sounds like it.
If it's them.
Do you know what the active ingredient is, or more than one?
No, it's green. I think zinc's involved, zinc oxide, and possibly eucalyptus, but I'd have to go and look at a pot of it. Okay,
that's fair enough. Which horseshoe do you use in cases of major hoof wall destruction? I would say that I didn't show a picture of it from the bottom of the shoe on. I used a heart bar with that, even all those years back, because we had lost so much hoof wall, and of course the heart bar is used to transfer load. And in fact, I think even today, although I think there's some marvelous digital support pads, you needed to be able to get at that wound. And I think, so I think I'd still use a heart bar to this day. So it was a hospital plate made on a heart bar shoe. Let's see, Dan Farrell, is there any research on advantages of copper coated nails? Does nail placement have any effect on introduction of foreign matter into the hoof wall? Sarah, I'll let you have a go at that first of all.
There was research done on copper coated nails. Stromsholm was involved. I actually tried to track down the research because apparently it was favourable. And I was actually one of the farriers. I think there was 10 of us across the UK that were submitting horn samples. And because it came back that the horse I was taking horn from had got some of the worst samples they'd seen. I didn't think the feet were that bad. But what they did show was the fact that, yes, it reduced the bacterial content immediately adjacent to the nail. So this is where I think the sales pitch went a bit wrong with them. It's not going to magically make the feet better, but it will reduce the incident of infection immediately next to that nail. So again, it's back to my every little help bits. No, it's not going to make the feet amazing, but if it helps them be less bad, that's a good thing. As I say, finding the actual published research, I hit a dead end on, so I don't know where it went to be honest.
Well, it was written by Brian Hampson of the Pollet stable, so it should be able to be found. And he basically, it certainly said to me, because I've chatted with him about this, and I felt that maybe the copper just creates a barrier, because of course some of these are also iron-eating microbes, and that's what encourages them. But he says that of course copper does have an antimicrobial effect all on its own, as we've sort of been alluding to, and copper sulfate. So I think it has a double effect, and yeah, the scientific study has shown that it has a measurable effect, as Sarah has just said. If it's part of a whole group of treatments, it's not just a one thing. But of course, we mustn't forget that just by banging a nail through a hoof wall, we are allowing microbes in. All right, let's see. Mark Rickard says client's horse barrel racer has overall poor quality hoof quality. A Sigafoo shoe, which is now called Sound Horse, lasted 3 weeks and came off along with a fair amount of hoof wall. The condition looks similar to hoof wall separation disease, but the hind feet, which are barefoot, have decent quality. Some success achieved with former hoof. Can a biopsy of the hoof wall help determine the cause of this condition? Well, you are the one that's done biopsies of hoof wall.
No, I just sent bits of horn away.
So who do you send it to?
Pardon?
Is there a recommendation to Mark that he sends it anywhere in particular?
Well, I was actually going to bring this up earlier when you said about other breeds having hoof wall separation disease. There is a farrier in the UK, I want to say it was Ian Gyjack. He had a horse he was convinced, not Connie, convinced a vet to do the same genetic testing, which of course they don't like doing if it's not Connemara, and it came back negative. So that was a bit of an interesting, was it was appearing the same, but wasn't genetically the same. I don't know whether I don't believe with the Connemara, the biopsy is of the horn. I think they take hair, to be honest. So again, it might be something as if a vet would do the same test to check, but I don't think it's the horn that they actually look at.
Okay. All right. So, well, Mark just adds a PS. This horse belongs to a vet student. She's knowledgeable about nutrition. So I don't think it's a nutrition problem. Okay. Well, we wait to hear. I just want to sort of finish on two questions. One's to you, Sarah, and one's to both of us. So the first one was that Brian asked, how long did your thesis take?
Oh, I don't actually want to add up the hours. I think my study was over 18 months. And that was just putting the data together. And then an awful lot of writing and an awful lot of editing, I seem to remember.
A lot leading up to it, and I'm sure you're still refining it, as we've seen from this lecture, and still thinking about this problem, which is great. We need experts in all sorts of bits. So there's a question here that I want to finish on to both of us, and it says, why not call it white line disease like everybody else? Well, Jane, clearly not everybody else, because Sarah and I was not calling it white line disease. But Sarah, why don't we call it white line disease?
Because it's not in the white line,
no.
Basically.
I think if you went to a doctor with a fractured wrist and he kept saying, we're going to fix your knee,
yeah,
you would really lose a lot of faith. And it's bizarre that it's got this name of a different part of the structure.
Well, I know you said in the comments about apologising for renaming it. The only reason I laugh about it is because I just wish I'd done that, because we sat in your office and you said, what are you going to call it? You can call it anything you want. And I went, I'm not going to complicate things. We'll just stick with Seedy Toe, because my brain was melting with everything else. But you have actually given a logical term to it, which is why I will accept it and go with it.
I hope it spreads far and wide, and because we need accurate terms to discuss these things. Now, Sarah, we have come to the end of this webinar. I hope everybody's happy. We've had lots of participants and attendees, and thank you all the attendees for coming. The most important people to me in these webinars is firstly the attendees, and secondly guest speakers. I think all of you who probably haven't heard Sarah speak, and I think she hasn't got about far and wide enough, mainly been
hiding in the dark,
stuck up in the beautiful Highlands of Scotland, but nevertheless, with the magic of webinars now, she should be more widely known. And I think we've already got some messages coming through saying how fantastic it was.
Could I add a very brief thing? you mentioned about the farrier tuition. I want to say that's not just me. That's the brainchild of Jay Tovey. I gained the mantle of probably just doing the theory side of things again because of distance, so one-to-one. But we've also got Michael Woods in Sweden on board for the diplomas now because it's taken off and I cannot deal with that many. So he's part of the team as well. So it's not just me. There's a team of us.
I've been railroaded into doing the fellowship course, which was last weekend. So yeah, good old Jay, he has these fantastic ideas and he ropes us in.
Thank you to him.
Like that a bit. All right. So I just want to thank everybody again. I hope you all enjoy the rest of your weekend. Enjoy your summer. We are going to get back to you all. We don't want to pester you with too many emails, but we're still going to do that. And we will let you know what our new subjects are, who our new speakers are, and we're going to take a break, but we're looking forward to doing it again. So thank you, everybody. Come here, Sophie. So Sophie does exist. Sophie. Not a big limit of imagination. So, okay, everybody, thank you very much.
Thank you very much. Thank you, Sarah.
Thank you. Bye-bye.
Bye.